Sometimes the future doesn't just creep up on you. It lands all at once. And that's exactly what just happened. We just lived through one of those weeks in AI. A week with 4 massive, totally distinct breakthroughs that could, seriously, reshape our world. It's that feeling, right? That sense that everything is speeding up all at the same time. That's what we're going to break down here. Because this isn't about just one company making a move. Nope. This is the entire field just leaping forward and on a bunch of different fronts.
And who's behind this? Well, it's 4 names you'll absolutely recognize: Meta, Google, ByteDance, and Microsoft. Each one of them just dropped a huge piece of the puzzle. And what's wild is that each piece points to a completely different future for AI.
All right, so first up, Meta. They just dropped a new vision model called Dino 3, and honestly, the sheer scale of this thing is mind-blowing. This is all about teaching an AI to see the world, but in a totally new way.
So the magic behind this is something called self-supervised learning. Now, think about the old way. You'd have humans sitting there for hours, painstakingly labeling millions of images. This is a car, that's a tree. Forget that. With this, the AI literally teaches itself. It just looks at a massive pile of data and starts finding its own patterns. And that right there is a total game changer for how fast AI can learn and grow.
And this is why it's such a big deal. The old way, that was the bottleneck. Relying on people to label stuff is it's slow, it's super expensive. Self-supervised learning, it just smashes right through that bottleneck. It lets the AI dive in and learn directly from this endless, gigantic ocean of images and videos that are already out there, no labels needed. And when I say the scale is immense, it's hard to even wrap your head around. Okay, so get this. The last version of this model, it trained on 142 million images. Sounds like a lot, right? Well, this new one, Dino 3, it processed 1.7 times billion images. That's not just a step up. It's more than a 10 times increase in its visual diet. Just incredible. And all that data created this massive 7 billion parameter core, what the devs call a frozen backbone. The best way to think about it is like a master chef who has spent a lifetime perfecting every single fundamental cooking technique. Now, the frozen part is the secret sauce here. It means you don't have to retrain this master chef from scratch for every new dish. Nope, you just hand them a new recipe, a tiny little adapter, and they can instantly apply all that deep knowledge to a brand new task. It's incredibly efficient. And look, this isn't some far-off theoretical thing. It's happening right now. This tech is already out in the wild, guiding robots to handle fragile stuff, spotting tiny cracks in bridges, and even monitoring wildlife from the air. And how cool is this? NASA's Jet Propulsion Lab is using it to help the Mars rovers see and understand what they're looking at, millions of miles away. And you want to talk about real-world precision? Check this out. The World Resources Institute used this to measure tree canopies over in Kenya, and they saw a 70% jump in accuracy. 70%! In a field like environmental science, that kind of improvement isn't just an improvement, it's a massive leap that completely changes how you make critical decisions about our planet. Okay, let's totally switch gears now and head over to Google because they are painting a completely different picture of AI's future. If Meta's whole story was about going massive, well, Google's is all about going micro. They just put out a model called Gemma 3, and it really is the other side of the AI coin. We're talking about an ultra-compact model that's built for one thing: hyper-efficient performance right there on your device. So yeah, think less giant, power-hungry data center and more like a tiny, brilliant brain living in your pocket. And the payoff? It's just stunning efficiency. This little model can handle 25 full conversations on a Pixel 9 Pro while using less than 1% of the battery. Think about that. That's powerful AI that can run all day long on your phone, and you won't even notice a dent in your battery life. It's wild. And that efficiency translates into something else: incredible speed for developers. Instead of needing thousands and thousands of examples to teach the AI a new trick, they can fine-tune it for a super specific task with maybe 10 or 20 examples. That's it. You could literally dream up, build, and deploy a custom AI tool in a single afternoon. That's a game changer. All right, for our third big breakthrough, we're looking at ByteDance. And they pointed their AI at a problem that is just notoriously difficult: hunting for bugs buried in millions and millions of lines of code. Yeah, there's a technical name for this, issue localization, but for developers, it's just a nightmare. Seriously, imagine trying to find one single typo in an entire library full of books.
That's what it's like. And sure, current AIs can try to help, but they often just get lost, or they start wandering down the completely wrong path.
But this new agent from ByteDance, which they trained using a framework called ToolTrain, it's different. The absolute best way to describe it is like a heat-seeking missile for bugs in code. It doesn't just guess, it strategically calls on the right tools in exactly the right order to hunt down the source of a problem with just incredible precision.
And hey, don't just take my word for it. The data completely backs this up. Their main model just edges out a really powerful competitor like Claude 3.7 Sonnet. But here's the part that really blew my mind. Their much smaller model, a 7 billion parameter one, when it's supercharged by this ToolTrain framework, it still outperforms other systems that are using way, way bigger models. It's all about making a small AI punch way above its weight class.
Okay, last but definitely not least, our final breakthrough comes from Microsoft. Now, this one might sound a little less flashy at first, but trust me, it could fundamentally change the daily life of every single person who builds stuff with AI. What they did was create something called POML. That stands for Prompt Orchestration Markup Language. But forget the fancy name. The simplest way to get it is this. It is basically HTML, but for AI prompts. It's a clean, standard, structured way to tell a large language model exactly what you want it to do. See, right now, if you look at how most AI prompts are built, they're kind of a mess. It's just this long, unmanageable string of text where you have rules and data and examples all jumbled up together. It's chaos. POML brings order to that chaos. It cleans it all up, organizing everything with these neat, logical tags, just like HTML, that make the whole thing clean, easy to read, and, crucially, reusable. And for anyone who actually builds with this stuff, this is a huge deal. It means your prompts are suddenly way easier to test and maintain. It lets you separate the logic of what you're asking from the formatting, and it plugs right into the tools they already use every day, like VS Code. It's really a move from a kind of chaotic art form into proper, structured engineering. So let's just pull back and look at the whole picture. In one single week, the world of AI took 4 giant leaps, but in 4 totally different directions. Meta gave us massive self-learning scale. Google showed us radical on-device efficiency. ByteDance delivered surgical precision for a super hard problem. And Microsoft gave us a new standardized way to build. And that leaves us with a really fascinating question, doesn't it? We're watching 4 completely different paths of innovation just explode all at once. So, which one wins out? Which of these futures, the one built on scale or efficiency or precision or standardization, which one is going to have the biggest impact on all of us? And which one is going to get here first? I mean, think about it. Is Meta's breakthrough in scale the thing that finally leads to truly general-purpose robots? Is Google's efficiency going to put a powerful, completely private AI assistant in every single one of our pockets? Could ByteDance's precision get us to a world of nearly bug-free software? Or is Microsoft's new standard going to become the universal language we use to talk to all AI? You know, these aren't some sci-fi far-off dreams anymore. These are the very real futures that this one single landmark week just put right on the table.